We use measurement in our daily life. For example, we go to a fruit shop and ask 1 kilogram of fruit or 2 kilogram of fruit, like this. Or if someone asks where the fruit shop is, then you will say it is a 2 kilometer or 3 kilometer away from here. And if you buy some milk from a shop, you may be asking to get 2 liter or 3 liter milk. In all these cases, you can see that there is a measurement involved in this, like 2 kg, 3 kilometer, 2 liter, etc. Here, the digit indicates the amount and kg or liter indicates its unit. Therefore, we can define unit like this. Unit is the quantity of a constant magnitude which is used to measure the magnitude of other quantities of same nature. Therefore, every physical quantity has two things. One is a numerical value like this, and the other is a unit. For example, if we want some sugar, how do we measure the amount of sugar we want? We can say that we want 5 kg of sugar. Here, this physical quantity has a numerical value and a unit. So, what are the qualities of a good unit? An ideal unit has the following qualities. It should be a convenient size. It should not create any confusion. The unit should be reproducible and it should not change with the space and time. Now let us consider the type of units. There are two kinds of units, fundamental unit and the other one is the derived units. So these are the two kinds of units. One, fundamental units, and two, derived units. Therefore, we can define a fundamental unit as follows. A fundamental unit is that which is independent of other units or which can neither be created nor be changed with any other unit. Mass, length, time, temperature, current, and amount of a substance are considered as fundamental units. The units that are obtained from fundamental units are called derived units. Derived units. Therefore, derived units are those obtained from fundamental units and are expressed in terms of fundamental units. For example, if we want to measure surface area, then what unit will we use? For example, if we want to find out the unit of surface area, how can we find out that? We know that the surface area is equal to length into breadth. This is equal to the unit of length into breadth is also the length. So it is actually length like this. So if we consider this rectangle, the length is here, we taken this as the length, and this is also the length. So the unit of this rectangle is equal to length into length equal to length square. Then what is the unit of volume? So let us find out unit of volume. We know that volume is equal to length into breadth into height. All these are measured in terms of length. So here we can see that this is a length. This is also equal to length, and this is also equal to length. So it is actually equal to length into length into length is equal to length cube. So the unit of volume is equal to the unit of length cube. From this, we can understand that surface area and volume are derived units of length. Now let us study what symbols will be used to express these units. Let us consider the basic units such as the length, mass, and time. A system of units known as a CGS system of measurement is used to measure these fundamental quantities. So in this CGS system, length is taken as length is measured in terms of centimeter, cm, and mass is taken in grams, and time in seconds. So as an abbreviation of all this, we take CGS system as centimeter, gram, and second. This is an old system of measurement. So we use another few system of measurement. The next system of measurement is FPS. In this system, the length is taken in foots and mass in pounds. And time, second. So this is the FPS system, foot, pound, and second system. This is a British system. And another one more system is there. It is known as MKS system. In this system, length is taken in meter or M, and mass in kilograms. Kg, and time again in second. Yes. So MKS system is mass, kilogram, and second. Now these system of units are no longer used and a new system called SI system is used, or it is called System International. This is actually a modified form of the MKS system. According to this SI system, the following symbols are used to represent the fundamental quantities. This chart shows the fundamental quantities and their units and symbols in SI system. Always we can use this standard system. Sometimes we want to measure large quantities such as the distance from the sun to earth. In such occasions, we write the magnitude of these quantities in powers of 10, like 10 raised to 0 is equal to 1, 10 raised to 1 is equal to 10, then 10 raised to 2 is equal to 100, 10 raised to 3 is equal to 10 into 10 into 10 is equal to 1000, like this. And also to express the small quantities, we represent that in the powers of 10 like this. 10 raised to minus 1 is equal to 1 by 10 equal to 0.1, and 10 raised to minus 2 is equal to 1 by 10 into 10 is equal to 0.01, then 10 raised to minus 3 is equal to 1 by 10 into 10 into 10 is equal to 0.001, like this. For example, the radius of Earth is equal to 6.378 into 10 raised to 6 meter. Similarly, the mass of hydrogen is equal to 1.67 into 10 raised to minus 27 kilograms. In all these cases, we use uh, the units in powers of a ton to express the large quantities as well as the small quantities. In SI system, we use the following units to express large quantities. According to this table, these large quantities are the following. Deca, it is expressed in 10 raised to 1 and the symbol is dA. Hecto, H, 10 raised to 2. Kilo, K, 10 raised to 3. Mega, M, 10 raised to 6. Giga, G, 10 raised to 9. Tetra, T, 10 raised to 12. Peta, P, 10 raised to 15. Exa, E, 10 raised to 18. Similarly, to express the small quantities, we use the following units. According to this table, the small units are deci, the symbol is D, expression is 10 raised to minus 1. Centi, C, 10 raised to minus 2. Milli, M, 10 raised to minus 3. Micro, Nu, 10 raised to minus 6. Nano, N, 10 raised to minus 9. Pico, P, 10 raised to minus 12, femto F 10 raised to minus 15, atto A 10 raised to minus 18.